DC motor write-up. So some of you have been asking what exactly are we supposed to do in terms of the write-up once we have made the motor. So the part that I want you to do mainly is to explain the working. Okay, explain working. Now what will you put in that? I have seen about half a dozen pieces of write-up. Some were good, some required something that needed to be added or something that needs to be explained. So for those who have completed the write-ups, for most of them I have given feedback and I'm working on it. I will give you feedback as I am checking your work. What I generally see is that before explaining the working part, people explain how they made it. Okay, so that is called as the construction. Now, in this DC motor that we made, there is nothing much that needs to be done in terms of explaining the construction. Okay, because it's a very simple DC motor, and the construction part, what will you write in any case? The safety pins have been put, then there is a copper wire, how you made the loop of the copper wire and then put it around over here, and then there is a bar magnet which has been placed over here, and how you secured the bar magnet using whatever rubber bands or tapes or whatever, and another rubber band over here. इसमें बोलने की कोई ज़्यादा बात नहीं है. Okay, so there is nothing much that you need to explain in terms of how that happened. What you can explain in that is the fact that you had scraped the insulation of the ends of the wire in a specific manner. Okay, so that part you can mention. So construction part of it, keep it to the minimum. What I want you to carefully explain is, why does the DC motor work at all? Okay, and in that I see that people often start referring to how the thumb rule can be used to explain the direction of current and how the magnetic field develops around it. So if there is a current carrying conductor, then you use the right hand thumb rule or the right hand clasp. So you hold the wire in this manner in such a way that your thumb points to the direction in which the current is moving. Then the way your fingers go around the wire, that explains the magnetic field. Okay, you don't have to explain this in detail. Okay, what you can say simply is that if there is an wire that is carrying current, Oster's experiment proved that there is a magnetic field around this wire. That's sufficient. You don't have to go into it in detail. But if you feel you want to explain this in detail, all right, I don't have anything against that. It will just make it a little bit lengthy, but that I leave to you. The part that I want you to really explain is the interaction between this. So you can say that since the pins are made up of metal and the copper wire is in contact with the metal and the metal is connected to the positive and negative terminals of the battery, when the metals are in contact, there will be a current that will be set up in this circuit. I will just illustrate that the difference. Say there is a current that is set up in the circuit, because of which the coil develops a magnetic field. Okay, now that part of it is the part that you have to explore. Okay, so I won't reveal it to you, but basically the idea is that in your textbook you will find it in the section with regard to electromagnetism. If you have a loop that is carrying current, and let us say that the current is going in this direction, okay, then this loop which is facing you will develop a specific pole. Okay, it can develop obviously a north pole or it can develop a south pole. So now the thing is, you have to figure out which pole is the side which is facing you, therefore which pole will be on the other side. So once you have figured that out, then you can use that result over here and say that therefore when the coil is facing the magnet, then there will be an attraction or a repulsion as the case may be. Okay, and then the coil gets a mechanical force on it, and because it can spin, it will spin because there is very little friction at these points, right? And once it starts spinning, that's when the part about the insulation comes in. So you can show that part also. That's a little bit harder to sort of show, but it can be done. So if you talk in terms of removing a part of the insulation of the wire, let's say that you have removed one part of it in the upper side. Okay, and on the other side, the wire does not have any insulation on it at all. So you have removed the complete insulation from that side. So now you can say that when the coil rotates, what will happen is that when the insulation part, this is the insulated part, when that comes in contact with the pins, the ends of the pins, then the current is broken. If the current is not broken, then what will happen is, again there will be a reversal of the polarity, and the reversal of the polarity will cause the coil to twist back. Okay, and that is the reason why you scrape off 1/2 or 1/3, 2/3 even of the wire on one side, but on the other side you scrape it completely off. That is to break the circuit and therefore allow the inertia to complete the turn. And once inertia takes the turn, when it turns through 180 degrees, again the wire will come in contact, again there will be a polarization, again there will be repulsion, and therefore the action will continue. So this part, if you can carefully explain with the help of diagrams, with careful wording, that is what I am expecting to see in the working. And if you do a good job of that, then in the first go itself, I can accept your draft. Any questions about this now? Okay, so then we will stop here. If there are any